Net carbon emission, carbon neutral, and net zero. These are the terms that we often hear from various government agencies, industry bodies, and organizations involved in environmental protection. In this short video, we will look at how to compute net carbon emission for an industry with multiple sources of energy inputs. Net carbon emission is defined as the total amount of carbon dioxide released into the atmosphere after accounting for any carbon removed through natural processes. The definitions for carbon neutral and net zero are also given here, but we will not discuss them now. Carbon emission is defined under two scopes by the Environmental Protection Agency of the USA. Scope 1 covers the emissions which are direct that occur at the industry, like operating a diesel generator as an energy source by burning diesel. Scope 2 covers which are indirect as associated with the use of grid electricity. Here, a typical electricity sources for an industry is shown. This industry has a contract demand of 500 kVA from the grid. It has a PV generation of 250 kilowatt, and as a standby it has a diesel generator of 200 kVA. These multiple sources provide the required supply to the industry. Meters are essential components for monitoring, and the same is shown here with meters M1 to M4, with M4 monitoring the load. The profile of the load of the industry is shown here on the top left graph. As seen, the load starts ramping up from 7 am onwards and reaches a value of about 400 kilowatt at about 8 am when the shift starts. The load is steady for the whole day and starts tapering down around 5 pm onwards with a reducing load. As mentioned earlier, this industry has a PV generation capacity of 250 kilowatt, which starts generating power at about 8 am and reaches a high value of about 230 kilowatt by noon. Again, with the reducing sun intensity, the generation starts ramping down and the generation ceases at about 7 pm. Here we can see the profiles of all the sources and the load. It is seen that with the PV generation picking up, the offtake from the grid reduces and it is shown in the orange line. Again, with the PV tapering off around 7 pm, the entire load is supported from the grid. For illustration, we have also included a grid failure duration from 7:30 pm to 10:15 pm, during which the diesel generator takes the load. With the grid power restored at about 10:15 pm, the load shifts to the grid till midnight. The consumption pattern is tabulated here. For convenience and ease of understanding, we have divided the day into 5 time zones. It is seen that from midnight to 7:45 am, the grid provides 1755 units. From 8 am to 6:30 pm, both the PV and the grid provide a total of 15,554 units to the load. From 6:45 pm to 7:15 pm, With no power from PV, the grid supports 535 units, and with grid failure from 7:30 pm to 10:15 pm, the diesel generator provides 1210 units. Again, with the grid power restored, it provides 145 units till midnight. The contribution for the day from the grid is 58%, PV 36%, and diesel generator is 6%. Given the basic data of energy sources and their contribution, now we can compute the carbon emission. The carbon emission is computed based on the carbon intensity for each of the sources, and the same is available in public domain for various countries. The carbon intensity is defined as the grams of CO2 emitted per kWh. One such table is shown here. As seen, the carbon intensity for France is 84.82, while for India it is 632.41. The final calculations for the net carbon emission is shown here. The industry has consumed 11,136 units from the grid, and with a carbon intensity of 632, this works out to 7,038 kgs of CO2 emission. Similarly, the emission due to diesel generators with carbon intensity of 900 works out to 1089 kgs of carbon dioxide emission, which finally adds up to 8,127 kgs of carbon dioxide, which is the net carbon emission. As the industry utilized PV source to the extent of 6,853 units in lieu of grid power, the avoided carbon emission works out to 4,331 kgs of carbon dioxide. Hope we have given you an overview of the calculations involved in the computation of net carbon emission. You are most welcome to post comments and feedback. Thank you.